to start spiraling some material back in that we haven't seen in a while, because we definitely want to go ahead and remember these ideas. They're going to be on the paper exams. These two problems are dealing with the mean and standard deviation. Do we remember what the formula for standard deviation was? Nope, it's been a while. Okay. So let's see here. Remember we used sigma sub x equals, it was below a big radical. Okay. We had to take a sum of some kind of difference. X minus there you go. That's exactly right. So it's the square root of the sum of the square differences between a term and its mean divided by the number of terms that we have. Okay, so this was going to be the standard deviation. What if I squared it? Then we'd have the what? The variance, yes. Okay, so we have the variance. Okay, so we had looked at how to do this by hand, but these are just focused on how to do these using the technology. So the first thing we got to do is put these values into our calculator. So I have that right in front of me. So you guys walk me through. I got my calculator here. Let me go ahead and get rid of these trig functions. Okay, so we're going to go to one. We want lists and spreadsheets. Okay. Yep. As long as you're labeling these, they have to have some kind of name, the column. I prefer just X and Y. Here, what are we talking about? Number of clients and frequency. What does it mean, frequency, by the way? There you go. Eli says the number of times that particular element occurs. Now, remember, when you go ahead and plug this information in, we go ahead and avoid this equals row. We're just going to avoid it. So, looks like I have 36. 39, 44, 45, 46, 48, 50, and 52. All right. Now I got that little shortcut. I'm going to hit Control 7. Gets me right back up to the top. And 36 has a frequency of 2, which means it shows up twice. 5, 9, 11, 15, 5. I believe it's 4, and 1. There we go. So I've got my data in. Now what? Okay, we're going to go to menu, statistics, stat calculations. Why is this one variable? We see two columns. Remember, frequency doesn't count. That just tells you the number of times that element happens. Yes. So saying the number of lists is just 1, so click OK. Now for X list and frequency list, this is where you're going to go ahead and delete what you have, and you're going to type in the headings that we started the problem with. Then I'm going to tab. Let's go ahead and backspace there. I'm choosing Y. All the information is going to show up in column D, and I'm going to click OK. All right, now this is the one we're interested in. Okay, sigma X. So my standard deviation is what? 3.28. There we go. And if I go ahead and scroll up, see, it gives me the mean right there is 45. Okay, so it gives me the sum of all my terms, 2,340. Gives me the standard deviation. There are 52 terms total. And it even provides me with enough information to create a box and whisker plot on the data. Okay, so there we go. Good. Okay, how many people remembered how to do that? Okay, a few folks. Okay, all right, good, 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 good. All right, so let me go ahead and get out of here. Control W. Do you want to save that? No. Okay, now we're going to go ahead and do the same thing for this next one. But what's the difference between number 1 and number 2? It's still a frequency graph, but what? There you go. It's broken up into class intervals. So I don't know what the actual data is. I just know how it's broken up and what the frequency is going to be. So when you're looking for, say, the mean, standard deviation, and it's broken into class intervals, what do we do? You use the midpoint. Yes, you use the midpoint of the interval. So for each of these, like this one, I'm going to use 41, 43, 45, and it looks like I go all the way to 53. Okay, so I'm going to come on over here. Same thing. Now, if you don't want to hit number 1 and choose lists of spreadsheets, remember you can just come down here and choose this icon in the middle. It's going to do the exact same thing. Okay, so X, there we go. Y, let's go ahead and put in the midpoints of my intervals. 41, 43, 45, 47, 49. Then we got 51 and finally 53. Control 7 gets me right back to the top. And then we don't know what the elements are, but I know I have 1 between 40 and 42. 1 in the second interval, 3, 7, 11. We got 5 and 2. Okay. Now what? There you go, menu. In fact, is it the same keystrokes? Yes, even though we're using the midpoint of a class interval, what we just did a moment ago doesn't change. I still want stat calculations. It's still one variable. Okay. Okay. Then we will choose the headings we typed in a moment ago. Tab, backspace out of that. We want that. Okay. It's going to show up in D. All right. So what is my standard deviation for the data? 2.66. If we're going to round to 3 sig figs. What should the mean be? Okay, so 48.27. Okay, nice. And then you have all the other same information that we had here. Good, 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 good. All right, so I figure the next, this first set of focus activities, I'll go ahead and kind of revisit some problems, some concepts that we haven't seen in a while. Again, just so we can, keep up with them. Don't forget, it's next month already on December what your rough draft is going to be due. December 13th. Okay, that's a Thursday. You still have quite a bit of time, but hopefully by this point, you've already started collecting your own data, whether you created your own survey or you're just going to an online source, some kind of reputable site, finding data to fit your IA topic. Okay. So I'll be giving you more information as we go along about that. But, think about the data you collect. How am I going to organize it? Would standard deviation be a good strategy to use? Can you show anything with that? Some of the top ones people tend to like to use, chi-squared. That's a really good one with our contingency tables. Okay, what's another one? Okay, what's that? Line of fit. Okay, good. The correlation, coefficient R, all that good stuff. Yeah, so you got a lot of great ideas. You can go ahead and do that. Has anybody actually written their rough draft yet? Okay. All right. So definitely in the next couple of weeks, you don't want to do this last minute because the more you provide me, the better I'm going to be able to help you out and give you some feedback. So in the next couple of weeks, try to start drafting a paper. Look at your outline, think about your topic. What's the best way to follow through your paper? Start with your introduction, then talk about what your topic is and go right into your data, and then you'll start to analyze it using whatever mathematical strategies you have. Okay, good, 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 good. Well, let me get out of here. Document B. Or no, I think I'm in the wrong one. Okay, so escape, Control W. Or I'll deal with this later. There we go. That'll work out too. All right, so there's your focus activity, the first one. So we'll put that to the side. Okay. Let's get back to conditional probability. We got to do a little bit of this on Friday, and then our seniors came back. There should be some extra copies over here. Let's take a look. Here we go. Okay. And did the code I gave you work for the website? Cool, cool, cool. All right, so we've been talking about conditional probability. And put simply, conditional probability is just finding the probability of a certain event, knowing that another event has already occurred. We'll get to the formula in just a second. So we started this lesson with our table here that breaks down a lot of our information, connecting it back to Venn diagrams and sets. What did mutually exclusive mean? Yeah, Eli. There is no intersection. That means the sets are disjoint. Yes. Okay, so if they do not have any elements in common, then we simply add the individual probabilities of each event to get the probability of the union. If they are not mutually exclusive, meaning there is an overlap, then to find the probability of the union, we still add the individual probabilities, but we're going to subtract off the intersection because that is going to be counted twice. Let's see. Then we went through several examples. We got to conditional probability. In fact, we've been using A and B, so just for the sake of argument, let's say if I'm given the probability of C given D. Okay. What would the numerator be for this one? The probability of what? The intersection of the two events. Okay. So the probability of C intersecting D. And what would I divide by? The probability of C or D? D. Whatever is given, the second item, that's what you always divide by. The probability of event D occurring. And then we went through, some extra examples. And I think we got halfway through one. I think we just finished up A, right? Okay. So we filled in this Venn diagram. We're on this particular example. Two events A and B are such that A is equal to 0.5, B equal to probability of B, I should say, is equal to 0.3, and the probability of the union of A and B is 0.6. All right. So let's just go ahead and pick up where we left off with B. The probability of B given A. The probability of B given A. Well, this would be the probability of B intersecting A over the probability of what?
Probability of A.
Probability of A. Remember, whatever is written second, that's what you're going to divide by as our probability. Okay. Now, would probability of B intersecting A be the same as the probability of A intersecting B?
Yes.
Yeah, so reversing that doesn't change anything. So we're looking at the Venn diagram. The intersect, that's 0.2. So what's the probability of A occurring?
0.5.
0.5. Okay. So we've got 0.2 divided by 0.5. You could break it up as I did on Friday, the 2/10 and the 3/10 because you get the 1 decimal place. But ultimately, what's it going to become? It should be 2/5, yeah. The probability of event B occurring given that event A has already occurred, according to this information, should be 2/5. Okay, good. All right. Well, do you guys want to go ahead and try one on your own to get the ball rolling?
Yeah, let's try it.
Okay. Let's at least see if we can set one up. What does that little tick mark mean on A? That's A prime. That's the complement. So we're looking for everything in the universe, but not in that particular set. Okay, so let me go ahead and erase this. So I'm looking for the probability, now this is C, of A complement given B. So I'm going to write out the formula given these two items here. So it'd be the probability of the intersection of A complement and B divided by what? The probability of B. Remember, it's always the second event that we divide by, the probability of that event. Okay. And especially when we're talking about the complement, I would probably go to the Venn diagram just because I'm a very visual person. Okay. But we're going to go ahead and do this one together then. So what's the intersection of A complement and B? It is just 0.1, that crescent, yes. Okay. So does anybody want me to go ahead and shade those regions to kind of help out? No? Okay. And Haley, you are brand new. Are you familiar with the complement? Somewhat? Okay. Well, I'll go ahead. Let me go ahead and shade it for you, just to make sure. Yes. So the complement of A is everything that's still in the universe, but not in that particular circle itself. There we go. So I would shade everything outside of A, and now I want the intersection of that with B, so I'll go ahead and do this one in red. Okay, and the only place that the two overlap is that crescent section, the 0.1. Okay, and what is the probability of B? 0.3. Okay. All right, so 1/10 over 3/10 would give me 1/3. Or, if I were to go ahead and write it as a decimal, I'd probably say either 0.3 repeating or change it to a percentage, 33.3%. Okay, what are we thinking?
The math is fun.
The math is fun? Well, obvious every day.
That's what I was thinking.
Okay, there you go. There you go. All right. Now, another intervention here. Here's some more problems that are not in your packet, but again, just give us a little more practice on this particular concept. It says, in a class of 25 students, 14 like pizza and 16 like iced coffee. One student likes neither, and 6 students like both. One student is randomly selected from the class. What's the probability that the student likes pizza and likes pizza given that he or she likes iced coffee? Okay, so the first thing we're going to do is set up the Venn diagram. All right, so let me get my figures here. I'm going to need my universe. Okay. Okay. Hopefully these are going to be about the same size. There we go. And it's close to the rectangle, close enough. There we go. All right. So I've got my Venn diagram. Now I already know they're going to be overlapping because it says what? 6 students like both. Okay. So take about 15, 20 seconds. Let's see if we can go ahead and fill in the entire diagram. Let's go ahead and say that this left circle is everybody who likes pizza, and we'll go ahead and say the other one is C for iced coffee. Okay, is everybody about ready? Okay. Well, we already know the intersection. It says 6 students like both, so I know that's got to go right here in the middle. Let's start with how many people solely like pizza? Where'd you get that? Yeah, because there's got this circle here for pizza has to add up to 14, and we've already got 6 like pizza. So yeah, it's got to be 8 like pizza, but not the coffee. And we can do the same thing for the other one. 16 people like the coffee. If 6 already like pizza, then 10 is what I'm looking for who like coffee but not the pizza. Am I missing anything? And then one student likes neither. So somewhere in the universe, we have to put that random student who doesn't like pizza or coffee.
I feel like his emotions are a little icy.
Well, better latte than never. Oh! See, on the first day back, you know you missed it, right? Or either that or you're thinking, dear God, 3 years of this. I'm about to go insane. Okay, we'll see. All right, but yes. You know what I always think about every time I work a problem like this? One of my favorite movies of all time, Zoolander. The famous scene where he's all bummed and his model friends are trying to cheer him up. And they're like, model friends?
I've never seen
You've never seen it? And they're like, orange mocha frappuccino. And then they go to the gas station and they're shooting gas all over each other.
What?
You've never seen it?
No.
Oh my God. Okay, we're going to have to watch it. Okay.
Yeah.
And they go, jitterbug. And they say, it's awesome. Okay, anyways. All right. So let's try this on our own. Now, I'll tell you what. Let's go ahead and do A together. And then I'm going to go ahead and give you a little bit of time to do B because that is a conditional probability problem. So what's the probability that the student chosen at random likes pizza? So it'd be 14 because it doesn't say they don't have to like coffee as well, but we know that 14 like pizza out of 25. Okay, so a little more than half. 14/25 won't reduce. Okay, so that's my probability. Okay. And let's take a look at B now. What do you think? 1 minute?
Yeah.
Okay. Now, what tells me that B is conditional probability?
Given that.
Given. Okay, there's that key word. Likes pizza given that he or she likes iced coffee. So you see what we've been doing with the letters? Maybe it would help if we wrote it out, the probability of pizza given liking iced coffee. Or you can actually write out the expression, whatever works for you. Okay, so let me go ahead and give you 1 minute. Okay, so with the Venn diagram, we should be able to get the two parts pretty easily. Oops. Now I got that song in my head. You put the boom boom into my heart. You send my soul sky high when your loving starts. Jitterbug into my brain. Bang bang. Come on, guys, take it.
I don't know it.
Oh, come on. It's Wham. Deadpool would be so sad. Who has not seen Zoolander? Oh my God. Oh my God. That movie is like hilarious.
I have to find a Swedish street. Because there aren't any rental services out there anymore.
Well, I mean, if you go to, yeah, it's not on Redbox, but if you were to go to, like, I have what is that? The Microsoft Store or on Xbox, whatever it is,
Oh, yeah.
where you can just go and look it up. You can probably find it that way or something. Yeah. I miss Hastings. Yeah, Hastings is good.
I really miss it.
There are still a few Hastings around, but ours closed.
Yeah. Wait, really? You guys, you know Pop Vinyl?
Yes, my wife and I collect those.
Yeah, the guy who owns Pop Vinyl is the owner of Hastings. Or he
Really?
was, but right before they sold it, he was the owner.
Oh, wow. I did not know that. Okay. All right. Now let's see if everybody was able to get the same answer. Okay, so with these variables, I'm going to say this is the probability of liking pizza intersecting liking coffee divided by what? The probability of coffee. Always, always divide by the given event. What's second? Well, let's see. What's the intersection? Okay, so this is going to be 6/25. That's the probability of liking both pizza and the iced coffee. And the probability of just the coffee is 16/25, right? So dividing by a fraction is the same as multiplying by the reciprocal. So 6/25 times 25/16. Those 25s are out. What is 6/16? 3/8. Okay, that's it. Okay, we got the last piece of the puzzle.
Finally, somebody got it. I've been trying to figure out a pun for a pizza for the past 10 minutes.
Yeah.
So, if you like have the same, if you have a common denominator like 25,
Oh, you like how we have 25 and 25?
yeah, do you really have to put those?
No, this is just the reasoning through. I mean, if you feel confident enough to go ahead and do that, a lot of times I still go ahead and do it because they'll reduce, but I go ahead and leave them like that so they'll just cross
Will
out.
there ever be like will there ever be a time when it'll be like 6/25ths over like 16/34ths or whatever?
I don't believe so. I can't think of a scenario where that'll happen because it's always out of the total number of outcomes that could occur. So they should be identical. Of course, there's always an exception to every rule, and I can't think of one off the top of my head, but I would feel confident in saying yes. How many people got that one right? Good, 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 good. Okay. Let's look at this one. Okay. In a class of 40 students, 34 like bananas. I find them very appealing myself. Appealing. Okay. 22 like pineapple. I tropic like it's hot. Tropic. I'm on a roll today. Telling you. Anyway. And 2 dislike both fruits. A student is randomly selected. Find the probability that the student, and then we have all these different scenarios here. So let's say this is for bananas, the left side. P for pineapple. Okay, so the first part here is just filling in the Venn diagram. Remember, getting a visual of the situation. Now, this one's different. It does not provide you the intersection, so you have to get creative like we did last week. So let me give you, let's say, 30 seconds. Let's see if we can fill in everything we need here. So we already know the universe is 40. So I'm going to go ahead and say U equal 40. Remember, these problems, there's always got to be, bless you, some way of filling in all the information. So there's one little item that always kind of gets the ball rolling. Okay. For me, it was the fact that how many people don't like either. Two. So I'm going to put 2 somewhere in the universe. Again, doesn't matter where. But this helps me out because I know whatever the number of people who like bananas and the number who like pineapples, that total should be what? 38. Okay, so what do I do? How does that help me? Spencer?
34 minus x, because x is the intersection, plus 22 minus x plus x to get the n7.
Okay, you are absolutely right. You're getting a little more complicated than I got. Okay, Eli, what do you think?
So there's 30 students at like the fruits, right?
Okay.
It'd be like 38 minus 34, for example. 4 is the amount of people who only like pineapples, not also like bananas.
There you go. Now, Spencer's way would have been perfect as well, but yeah, if I know that this whole circle here for bananas has to add up to the 34, but that everything adds up to 38, yeah, the difference of the two, there should only be 4 people who like pineapple.
That's so easy.
Okay. Kiana, does that make sense?
Yes, that's so easy. That's not what I did, but.
Oh, hey, but did you get it?
Yes.
Okay, there you go. Now, this is where we can start to work backwards because we have one area. How many people like pineapple? 22, and we've already got 4, so 18. And now 18 plus what will give me the 34? 16. Okay. And remember, it doesn't matter how you start. I started with the bananas. Let's go ahead and take that off again. Let's say we started with the pineapple this time. We know that 22 should like pineapple, so this whole circle here is 22, but that all of it should be 38. So what's 38 minus 22? 16. And see, going back the other direction, it's still going to work. So for the 34 who like bananas, that would still be 18. And then for the 22 who like pineapple. Okay, how many people got that Venn diagram together correctly? Okay. Is it making sense, though? Okay. All right, good. Now we can go ahead and start running through these probabilities. What's the probability that a randomly chosen student likes both fruits? Yeah, so this would be 18 out of 40, which would be 9/20. Okay. Almost 50%. Not quite. All right, let's try B. Likes at least one fruit. There you go. So it's the key word here is at least. So it's okay that they like both. So even though they only like bananas, they only like pineapples, they like both, they all at least like one. So yeah, this is 38/40. And that would be 19/40. Okay. I was just saying if you're paying attention, yes. And obviously you were. Can't get one past you guys. Huh?
Weren't you glad we were?
Okay, now the last two. Now, what kind of probability problems are C and D? They are conditional probability, because what's that word that pops out at us? Given. Okay. So let's go through C together, and then I'll have you try D on your own. So it says the probability that a student likes bananas. Okay, so I'm going to go ahead and put B, given that he or she also likes pineapples. Okay, so the way I'm going to write this out is the probability of the intersection of the two. Yes, always divide by the probability of what's given. So the probability of P. So we already found the probability of the intersection. Okay, we found that to be 9/20ths over. What's the probability of liking pineapples?
22, 22.
Now it would be 34/40ths, right? Would everybody agree?
Yeah, no.
Oh, I'm sorry. Yeah, I was looking at bananas. I'm sorry. That would be 20. Yeah, you're right. 22/40ths. Give me a break. It's a Monday. 22/40ths. So that would be 11/20ths, right? Okay. And this is what Peyton was asking about a second ago. We could multiply by the reciprocal, but the fact that the denominators are equivalent should be 9/11ths. So the probability is 9 out of 11 that a person likes bananas, given that he or she likes pineapples. Is conditional probability starting to make sense?
Yeah.
It's just finding the probability of an event knowing that another event has already occurred. Okay. All right, so let me give you an opportunity to take a look at D. Dislikes pineapple given that he or she likes bananas. So how would I write dislikes pineapple? Okay, there you go. So we're talking about its complement. There you go. Given he or she likes bananas. All right, so let me give you 30 seconds. Let's see if you guys can come up with the correct probability. Oh, I'm sorry. Okay, by show of hands, how many people believe they have the answer? Okay, so that's a decent number of hands going up. Carolina, what do you think? 9/17? What do you guys think? So close. I got 8/17. I got 8/17. Let's go ahead and look through it. Okay, so the formula, this would be the probability of the complement of liking pineapple, so disliking, intersecting with liking bananas, over the probability of what? Bananas. Always divide by the given probability. Well, if we're looking over here, like I did before, the complement is going to be everything outside the pineapple. Okay. And then we are wanting intersecting that with the bananas, and we're only looking for that crescent section. So I'm looking at, nope, don't want to do red. So that would be 16/40ths, which would be, what is that, 2/5? Okay, over the probability of liking bananas, which would be 34. Is that the number of people who like it? 34/40ths, and that would be what, 17/20ths? Okay. Is everybody okay with how I got that? Okay. And then here, they're not the same, so we definitely want to take a look at the reciprocal. 2/5 times the 20/17. So the 5 and the 20 have a common factor of 5. Multiply across 8 out of 17 is my probability. How many people got that one right? Good, 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 good. So we got close. We got really close. Okay. Did we see where we made our mistake?
Yeah.
Okay, good, 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 good. What's that beep? Oh. What's that beep? All right. Well, we have a couple of rules here, just a few. But before we get on to some next problems, we'll just kind of read through these. But I'll tell you what, it's 2:03. We're going to go ahead and stop today because I really want to see that clip now. Okay.